Our next lesson in geometry is called Geometric Postulates. Our goals for this lesson are to apply postulates to solve word problems, identify characteristics of postulates. Did you know that the foundation of mathematics involves undefined terms and assumptions? For example, a postulate is a statement accepted without proof. Postulates are the next logical step from definitions. Every mathematical system must have postulates. From postulates, defined terms, and undefined terms, it's possible to use logic and arrive at a theorem, a statement that can be proved. The selection of postulates for a mathematical system is difficult work. Proper selection is important because a theorem can only be true if the postulate's true. It is generally agreed that for postulates to be of any important significance, they must be independent and hopefully complete and consistent. For a set of postulates to be independent, each postulate must be able to stand alone. A postulate cannot be proven or deduced from another postulate. For a set of postulates to be complete, an adequate number of postulates is needed to sufficiently describe a system. For a set of postulates to be consistent, no postulate within the system can contradict another one. Postulates in geometry are sort of like the rules of a game. The rules determine how the game is to be played and what makes it different from other games. We have seen from our historical discussion that We have seen from our historical discussion that there are many different geometries. These differences arise from their postulates. So we're going to talk about 5 postulates about points, lines, and planes, and these are known as Hilbert's axioms of incidence and order. Okay, so I want you to get your sheet of paper that has your theorems on it. Okay, I want you to skip a space wherever you're at. Don't get a new sheet of paper unless you're completely out of room. Okay, and we're going to go ahead and write today's dates. We're going to write axioms of incidence. Okay, I'm going to put a P for postulate. You're welcome to write it out if you want. Postulate 1, a line contains at least 2 points. Postulate 1A, a plane contains at least 3 points not on one line. Not all on one line. Postulate 1B, space contains at least 4 points not all on one plane. Space contains at least 4 points not all in one plane. Okay, postulate 2. It's Through any two different points, exactly one line exists. You would think that would be a fact, but it's just a postulate. Through any two different points, not only. Exactly. One line exists. Okay, we said postulate 1, a line contains at least 2 points. Otherwise it's not a line, it's a point. Postulate 1a, a plane contains at least 3 points, not all on one line. So if you have 3 points that are not collinear, they're on a plane. Okay, postulate 1b, space contains at least 4 points, not all in one plane. Postulate 2, through any two different points, exactly one line exists. Okay, postulate 3 says through any 3 points that are not on one line, exactly one plane exists. Through any 3 points that are not on one line, exactly one plane exists. Okay, postulate 4. Postulate 4 says if 2 points lie in a plane, the line containing them lies in that plane. Postulate 4. If 2 points lie in a plane, the line containing them lies in that plane. And we're going to talk about one more. We're going to talk about postulate 5. If 2 planes intersect, then their intersection is a line. If 2 planes intersect, then their intersection is a line. Okay, we said postulate 3, through any 3 points that are not on one line, exactly one plane exists. Postulate 4, if 2 points lie in a plane, the line containing them lies in that plane. And postulate 5, if 2 planes intersect, then their intersection is a line. Okay, the illustration in your lesson depicts Hilbert's axiomatic relationships. The video presentation below it illustrates many of the same concepts, but because of technical restrictions, only line segments and partial planes are shown. These illustrations will help you understand special relationships, including non-dimensional points, one-dimensional lines, two-dimensional planes, and three-dimensional space. It's intriguing to think about. You will actually be viewing an implied three-dimensional bug being displayed on a two-dimensional plane. Okay, postulate 1, you have written down, postulate 1, a line contains at least 2 points. Well, it gives us more information about lines, planes, and space. It tells us the minimum number of points that each of them has. This postulate states that a line cannot just have 1 point. A plane cannot just have 2 points. Space cannot have less than 4 points. Okay, postulate 2 says through any 2 different points exactly one line exists. Well, it tells us that for any 2 points, only one line can be drawn containing them. We can also say that 2 points determine a line. Exactly one means at least one, but no more than one. Okay, in your notes we put postulate 3 said through any 3 points that are not on one line, exactly one plane exists. So postulate 3 tells us that if we have 3 non-collinear points, then only one plane contains them. We can also say that 3 points determine a plane. It reminds us that the plane, okay, if I were to draw a plane, I don't know how much room I have here. And I label these A, B, and C. It reminds us that this plane contains, there's A and B, so it's going to contain line AB. Line AB is on that plane. This says that line BC is on this plane. This says that line AC is on this plane. Okay? Because if the points are on the plane, then the line's on the plane. Postulate 4. Postulate 4 says if 2 points lie in a plane, the line containing them lies in that plane. Postulate 4 tells us that if we take 2 points of the plane and determine a line with them, then the line is entirely on that plane. Okay, postulate 5 tells us if we take 2 planes, Postulate 5 says if 2 planes intersect, then their intersection is a line. So postulate 5 tells us that 2 planes cannot intersect in a point, but in a line. Okay, and if you think about it, if you get confused, draw it. If your teacher's ever told you that, let's say I have a plane, this is a plane, and I have another plane, this is a plane. Okay, this is where they intersect. That's a line. So they don't intersect at a point, they intersect at a line. Okay? Alright. Now look at the page we just wrote. Let's answer some of these questions. Number 1. Now which of the postulates that we wrote on our paper talk about 2 planes? Well, postulate 1 says a line contains at least 2 points. That's talking about a line, but that's not talking about 2 planes. Postulate 1a says a plane contains at least 3 points. That's talking about 1 plane. It's not talking about 2 planes. Postulate 1a says space contains at least 4 points not all on one plane. That's talking about space and one plane. Postulate 2 says through any two different points exactly one line exists. That doesn't even mention two planes. Postulate 3 says through any 3 points that are not on one line exactly one plane exists. See, that's still just one plane. Postulate 4 says if 2 points lie in a plane, the line containing them lies in that plane. So that's still only talking about one plane. Postulate 5 says if two planes intersect. Okay, so this is the one that talks about two planes. So postulate 5 is the one that talks about two planes. Okay. Okay, let's look at number 2. I think on this one, instead of doing the odds, we'll do the first 6, and then I'll let you do the rest of the lesson, or the first 7. Number 2, how many lines are determined by 2 points? Okay, look at your paper we just wrote. If we have 2 points, how many lines do we have? Okay, look at postulate number 2. Postulate number 2 says through any two different points exactly one line exists. So the answer number 2 is 1. You can only have one line. It makes sense, right? If I make 2 points, I can only draw one line connecting those 2 points. Okay? Can you think of another line that I can draw containing those 2 points? No. Okay, let's look at number 3. Select the postulate that states a line is determined by 2 points. I think I just told you that one. Okay, postulate 2. Through any two different points, exactly one line exists. Okay? Okay, true or false? Let's look at postulate number 3. Postulate 3 states that exactly one plane exists through any 3 points. True or false? Well, that's false. Because this says postulate 3 states that exactly one plane exists through any 3 points. It says through any 3 points that are not on one line exactly one plane exists. Okay, well, let's draw it. Okay, if we're not sure, let's draw it. What if I have this? Okay, I have 2 planes. What if I have a point here, a point there, and a point here? See, that's 2 different planes. That's 2 different planes, but what if I have a plane, what if I have one that's like this? See, those are all on the same line. I still didn't draw that very well. What if they're all 3 on the same line? The problem is, this says 3 points that are not on one line. Okay, so that's false because they could be on a line. Number 4. Select the postulate that specifies the minimum number of points in space. Look at your paper. Which postulate specifies the minimum number of points in space? Okay. Which postulates mention space? Okay, well, postulate 1b mentions space. It says space contains at least 4 points not all on one plane. Okay, so it's going to be postulate 1b. In fact, I think that's the only one that mentions space, isn't it? Okay, let's do number 6. Look at your postulate page. Select the postulate that states points A and B lie in only one line. Okay. A and B lie in only one line would be postulate 2. Through any two different points, exactly one line exists. We can only draw one line. Alright? Alright, let's look at number 7. A table with 4 legs will sometimes wobble if one leg is shorter than the other 3, but a table with 3 legs will not wobble. Select the postulate that substantiates this fact. A table with 4 legs will sometimes wobble if one leg is shorter than the other 3, but a table with 3 legs will not wobble. Why? Which postulate tells me why? Which postulate substantiates this fact? Okay, did you find it? Well, let's look at it. Let's do this together. Postulate 1, a line contains at least 2 points. Does that have anything with 3 legs? No. Postulate 1A, postulate 1A, a plane contains at least 3 points, not all in one line. Space contains at least 4 points, not all on one plane. Those are all talking about points. Postulate 2, through any 2 different points, exactly one line exists. Postulate 3, through any 3 points that are not in one line, exactly one plane exists. Okay. Through any 3 points that are not in one line, exactly one plane exists. Okay, so it's going to be postulate 3. Okay. And the reason for that is if you have 3 points, they're all in the same plane. So the legs are not going to wobble. But if you have 4 points, let's see, which one talks about? Postulate 1B, space contains at least 4 points, not all in one plane. Now, if those 4 points are not all in the same plane, then the 4 legs are not going to be the same length. Okay, and it's going to make the table wobble, is what that is saying. But it is postulate 3. Okay? Okay. I want you to go through this. I want you to finish this lesson, study your notes.